Next snippet is from our top module and has two major halves. The top half, including all the assignment statements, covers all the sprites, positions, and the general field and field lines that are defined for the VGA. The bottom half covers all the calls to the different modules, including player motion for both players, puck states, and the VGA display, taking everything we need from them. Next, we have more calls to different modules, including PS2 receiver, our keyboard input module, and 7-segment display, and the different menus. This, in addition to everything before it, goes into the always block at the bottom, where the VGA outputs are defined through an active high or logic statement. In the next always block, we define the different game states and mode states using the output of the aforementioned PS2 receiver, where each key has its own unique 8-bit identifier. This allows us to interpret the different inputs across the entire game, not simply for the different states.
In puck states underscore FSM, the state definitions are at the top. We have a setup state, 6 directional states, 4 held states, and 2 goal states. The initial block of code specifies that if the space value is set to 0, then the automatic position of the puck and players is set to the setup state. If there is a collision wherein the puck overlaps with any player, then the state is set to the held state to that respective player. When the puck is in the setup state, its speed in the X and Y directions are set to 1. The scores of both players are set to 0, and the position of the puck is centered on the screen. If the puck is in the NW state, then it is moving up and to the left with respect to the screen. If the puck supersedes the ceiling or the left wall while it is in the NW state, then depending on the mode, the next state of the puck is changed, as well as the position and speed. If the puck manages to overlap with a goal, then it counts as a goal for the person on the opposite end. Once the puck overlaps with a goal, it goes into the goal by state. This goal by state acts as an intermediate state to allow for future additions to the code. Once the puck is in a held state, its speed in X and Y is reset to 2. The puck's position is always relative to the player's position. Once in the held state, the puck can be shot by the player in 3 different directions, as well as switched positions depending on user inputs.
Our player motion module determines how the players move based on the keyboard inputs. What's interesting about this is not the player physics, which means if you press W, it moves up, if you press S, it moves down. What's interesting is how we were able to get 2 players to play on the same keyboard. Originally, we had, when the keyboard for input for W is pressed, we move up. But this only allowed 1 player to move at a time because the keyboard cycles through based on the clock, where we use temp variables to determine that if W is pressed, a temp variable W goes high, and then A, S, and D, the other directions, go low, and vice versa when one of the other directions is picked. And as long as that variable is high, it moves according to the player physics, where you have collisions at the boundary and the midpoint, and this works for both left and right. And this allows us to have 2 people playing simultaneously, or at least what looks simultaneous. The letter map module allows us to lay out each letter on a 5x5 grid, so that way when we output it to the VGA, it shows up on the screen in the letter that we want. Take the letter E, for example. It has 4 constituent parts: the leftmost vertical line, and then the 3 horizontal lines that come out of that vertical. For each, we break it down into its 4 constituent parts, E1, E2, E3, E4, and for each part, we build it from the blocks of that 5x5 grid in the layout that we have created. From there, we can then go down to a case statement where, based on an ID input that we have in our letter map module, we can then determine whether it's going to be, say, E. And if E is created, we then use our output variable value and we add each of the constituent parts. So that way when it's outputted as the entire letter E. So it's properly outputted by the VGA.
In our menu module, we define an ID for each individual sprite, as well as the width and height and pixels of each sprite, and the X and Y coordinates at which each sprite starts on the screen. The module then calls on the letter map module for each individual sprite, such as the letter E. It passes to letter map the X and Y coordinates at which the VGA is currently scanning, the X and Y coordinates at which each sprite starts, the ID of that individual sprite, the width and height of each individual sprite, and then sets the output of letter map to a wire. In this mux that we have, the wired outputs are all summed together to create the full menu screen. The mux is dependent on what game mode we're in, and depending on which mode we're in, the menu screen will display hockey, mode, and then the current mode. We display our game over screen the same way that we display our menu screen. First, we've got our menu screen, and you can see that we're able to switch through modes 1 through 8, and then back down from mode 8 to 1. So you can see you can collect the puck, and then switch the puck up and down, which mimics stick handling. And then with the puck collected, you can move the player left, right, up, and down, and the puck will stay with the player. And you can collect the puck after it's been shot, and then you can shoot the puck into the pink goals. Moving, shooting, and stick handling are done with the keyboard, and we made it so that the puck shoots out at a random direction each time the game starts. This is showing that in addition to being able to shoot the puck forwards, you can also shoot it at an angle upwards, regardless of which position the puck is in after stick handling. And you're also able to shoot the puck at an angle downwards. And this also showcases the puck colliding with the wall and continuing to bounce. This is showing our scoreboard on the 7-segment display. So first, the player on the right is going to score a goal, and you'll see their score go up on the 7-segment display. And then the player on the left is going to score a goal, and their score will go up on the display. Here we're showing that once a player scores 7 goals, the game will end and the game over screen will appear. In mode 1, the puck and players move at a normal speed, the puck will bounce off of the walls, and the goals are in their normal positions. In mode 2, the puck and players still move at a normal speed, but now the puck will pass through the walls instead of bouncing off of them. In mode 3, the puck will bounce off of the walls, but now the puck and players both move much faster. In mode 4, the puck and players move much faster, and now the puck will pass through walls and not bounce off of them. In mode 5, the players move at a normal speed, but now the puck speed will increase with each bounce, and the goals move up to the top of the screen, disappear, and then reappear at the bottom of the screen after a given time interval, and continue moving upward. In mode 6, the goals are moving, and the puck passes through the walls. In mode 7, the puck will bounce off the walls, but now the players move at an increased speed and the goals are moving. In mode 8, the players move at an increased speed, the goals are moving, and the puck passes through the walls.